Day 2 of Exponents. Our essential question tonight is how can you use inductive reasoning to observe patterns and write general rules involving properties of powers? So that is going to deal with the activity I had you guys complete before starting this video, which was the Exploring Exponent Discovery Worksheet. Okay, by kind of filling that in, you guys were able to observe patterns and write maybe some rules about some properties of powers. Our goal today, though, is to simplify exponents using 3 different properties. So our first property is the product of powers property. The second one is going to be power of a power property. And the third one is going to be power of a product property. And we will get into those in more specifics later, but that is their general name. All right, our first goal on the Exploring Exponent Properties was to complete the table below using inductive reasoning. So this is where our essential question is going to come in handy. So it's asking us to simplify this product right here. So we have 2 squared times 2 to the 4th. If I were to write it out in repeated multiplication, which is going to be right here, okay, I'm going to go ahead and write out what 2 squared times 2 to the 4th looks like as it does in expanded form. So that's going to be 2 times 2, which is going to be 2 squared. And then the second one is going to be times 2 times 2 times 2 times 2. So now I have 2 times 2 times 2 times 2 times 2 times 2. And if I were to express that as a power, my base is 2, and my exponent here is going to be 6. So 2 squared times 2 to the 4th is 2 to the 6th power. If we were to continue on to our next problem, we have negative 3 squared times negative 3 to the 4th. Again, here our base is negative 3, so we're just going to go ahead and write it out. Negative 3 times 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 negative 3. All right, so we have negative 3 times itself 6 times. So this power is negative 3 to the 6th power. If I were to do the next one, 7 times 7 times 7 times 7 times 7, which is going to give me 7 to the 5th power. If I were to do the next one, this is going to be 5.1 to the 7th power. The next one will be negative 4 to the 4th power. The next one will be 10 to the 8th power. And then the final one will be 1/2 to the 5th power. So our goal is to write a general rule for multiplying 2 powers that have the same base. So in all of our examples here, our bases were the same. We had 2 squared times 2 to the 4th. Both had a base of 2. We had negative 3 squared times negative 3 to the 4th. Both had a base of negative 3. Our third example was 7 to the 3rd times 7 to the 2nd. Both had a base of 7. Okay, so they have the same base. So what do we do with their exponents? Oh, our general rule is to go ahead and take both exponents and add them. So our general rule is a to the mth power times a to the nth power, both meaning they have the same base but maybe different exponent numbers. We're going to go ahead and add their exponents. And the way that we can kind of check our work here is if we look back at the examples, you're going to notice that 2 had an exponent of 2 and 4. 2 plus 4 gave us 6. The next example had an exponent of 2 and 4. 2 plus 4 also gave us 6. For 7, we had an exponent of 3 and 2. 3 plus 2 gave us 5. So whenever we have the same base and we're multiplying, okay, that's another keyword, we're multiplying with the same base, we're just going to go ahead and add our exponents. We call this rule the product of powers property. Our second example here says to write the expression as a single power. So what they mean is to simplify your exponents here. So we have a power of a power right now because our exponent of 2 here is now raised to 3. Okay, so we're going to go ahead and simplify that as a single power. And in order to do that, we can expand it and then put it all back together. So what this expression simply means is 3 squared times 3 squared times 3 squared, which then becomes 3 times 3 times 3 times 3 times 3 times 3. Which when we go ahead and count how many 3's we have, we're going to have 6 3's. So to write this expression as a single power, it's going to be 3 to the 6th power. If I go ahead and expand my second power of a power, I'm going to get 2 squared times 2 squared times 2 squared times 2 squared, which then expands to 2 times 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 2, which then becomes a single power of 2 to the 8th power. All right, so then if we just kind of continue on, this next one, C, is going to be 7 to the 6th power. Our next one will be y to the 9th power, and then our final one will be x to the 8th power. If we wanted to write a general rule, okay, for finding a power of a power, we go ahead and we take our exponents here and we multiply them. So this becomes a to the m times n. And then this would be our second property, which is power of a power property. All right, so our last rule here is power of a product property. So in order to find that rule, we're going to go ahead and answer 3 in order to write our rule. So 3 is telling us to write the expression as the product of 2 powers. And so what that means is we need to take our power, our exponent here, okay, and we need to apply it to both of these bases here. Because this 3 is on the outside of a parenthesis and it's being applied to everything within it. So you're going to get 2 to the 3rd times 3 to the 3rd. And you're done. Now you have the product, which is multiplication, of 2 powers. Here's 1, here's 2. All right, so let's do the next one. Here our exponent 2 is going to be applied to our base of 5 and our base of 2. So we're going to get 2 to the power of 2 times 5 to the power of 2. For C, again, exponent of 3 is going to be applied to the base of 5 and 4. So I'm going to have 5 to the power of 3 times 4 to the power of 3. For D here, this exponent of 4 is not only being applied to A, but it's also being applied to 6. Every single thing within the parentheses needs to get the exponent applied to them. So our base of 6 is going to get an exponent of 4, and our base of A is going to get an exponent of 4. So that would be the product of 2 powers. Same thing goes with E. 3 is our base with an exponent of 2, and x is our base with an exponent of 2. All right, the last little thing we have to do is write our final rule for finding a power of a product here. Okay, when we have 2 different bases, so A and B are 2 different bases, but they both have an exponent of m. So all you really have to do is kind of like the distributive property. It's going to be A to the m power and B to the m power. So that's our final rule here. That's the power of a product. So today in our lesson we've learned three different properties. The first one was product of powers property. The second one was a power of a power property, and the third was power of a product property. And I don't expect you guys to remember all the names of the properties. I just expect that you remember the rules. All right, so let's do a quick recap of all three rules that we talked about today. The first rule that we talked about was the product of powers property. And that property works when you have two powers being multiplied by each other and they have the same base. So same base being multiplied, you can go ahead and add their exponents like such. So 4 to the 2 plus 3, which becomes 4 to the 5th power. Needs to have the same base, which this problem does, and you need to be multiplying the powers. You cannot be adding. It does not work with addition because exponents is repeated multiplication. Okay, so that's important to note. The second rule that we talked about was power of a power property. And that means basically you have a base that has an exponent raised to another exponent. So if you're looking at here, we have 4 to the 6th all to the 3rd power, which essentially is taking our exponents, multiplying them together to give us our new exponent. So here, 4 to the 6th to the 3rd power becomes 4 to the 18th power. The last example was the power of a product property, which is kind of like distributive property. You're basically taking your exponent and you're applying it to everything within your parentheses. So 3 times 2 to the 5th power becomes 3 to the 5th power times 2 to the 5th power. You'll also see examples like 6x squared all to the 3rd power. Again, you'll take your exponent of 3, you'll apply it to the x, and you'll also apply it to the 6. So that's going to go ahead and become 6 to the 3rd power times x to the 6th power. All right, so I've given you some examples to kind of practice on your own. I encourage you to stop the video, try these few examples on your own, and then hit play to find out the answers. All right, now that you've kind of tried these on your own, I'm going to go through these super quick. So we have our first property where we just go ahead and we see that we have the same base. They're being multiplied, so we can add their exponents to give us 2 to the 9th power. In our second example, again, we have the same base and it's being multiplied, so I can go ahead and add the exponents. This -5 is actually to the 1st power. Even though it's not there, explicitly it's there. So this becomes -5 to the 7th power. For our third example, again, go ahead and add them. You're going to get x to the 10th power. For our next two sets of problems here, we have a power of a power, so we are going to multiply our exponents here to give us 3 to the 12th power for our first one, and then w to the 20th power for our second one. And last but not least, we have our double distributive property, essentially in the first one here. We're going to take our exponent of 3 and we're going to apply it to x, our base of x, and then our base of 2. So that becomes 2 to the 3rd power and x to the 3rd power. For our second example, we're going to take our exponent of 2 and we're going to apply it to our base of y, our base of x, and our base of 3. So this becomes 3 to the 2nd power, x to the 2nd power, and y to the 2nd power.